Hello and good morning to everyone. So our today's lead code question is 3742, that is maximum path score in a grid. So basically in this question we are given a am cross and grid where each cell contains all the either of the three values 0, 1 or 2, and we are also given an integer k. And what we have to do is we have to start from the top left corner 0, 0, and we have to reach the bottom right corner, that is m minus 1 comma n minus 1, by moving only either in the right direction or in the down direction, right? And each cell contributes a specific score. So if the cell value is 0, that means it will add 0 to your score and the cost will be 0. If the cell value is 1, that means it will add 1 to the score and the cost is 1. Similarly, if the cell value is 2, it will add 2 to the score and the cost is 1. And what we have to do is we have to return the maximum score. We have to return the maximum score which we can achieve by moving from 0 0 to m minus 1 n minus 1. But the thing is that our total cost should be lesser than or equal to k to move from 0 0 to m minus 1 n minus 1. And if there is no path exists, means no path exists whose cost is lesser than or equal to k, then we have to return minus 1, right? It is given in the note that if we reach the last cell but the total cost is greater than k, then the path is invalid and we have to return minus 1 in that case, right? So let's see some examples to get the question more clearly. So the first example is we are given a grid 0, 1, 2, 0 and k is equal to 1. So first path can be this path, right? This path. So see, the total score is of this path is 1 and the total cost is also 1, right? The other path can be this path. So even for this path the score is 2 and the cost is 1. So both path has cost lesser than or equal to k. So we choose that path which has maximum score. So it has score 1, it has score 2. So we will be choosing this path. So our output is 2. The next example is in the next example we have grid as 0, 1, 1 and 2. Again we have two paths, this path and this path. For this path the score is 3 but the cost is 2. Similarly for this path also score is 3 but cost is 2. But our allowed cost k is equal to 1. So both path has cost greater than k. So none of the path is valid. So we have to return minus 1, right? So let's see the constraints. So for the constraints we have m and n, that is the number of rows and number of columns, can be up to 200, right? And k can be up to 10k power 3, and grid of 0, 0 will always be 0, and each value of grid of 0 can be grid of I, j can be either 0, 1 or 2, which is mentioned in the question. So let's see the approach. So what we have to do is we have to move from 0, 0 to m minus 1 n minus 1, and we can only move either in the right direction or in the down direction. And each cell will give us a score and a cost associated with the score. And what we have to do is we have to keep the cost, we have to keep the total cost lesser than or equal to k for the path to be valid, right? So basically this question is like a maximum path sum, but there is one more constraint of the cost. So if you use normal dp, that is dp of ij, which is directly equal to maximum score. But the thing is that this same cell I comma j can be reached by different paths and with different costs, right? So suppose path 1 gives us a cost of 1 and a score of 5. Path B gives us a cost of 3 and a score of 8. So if we go with normal DP, then we will take this path which is having maximum score, that is 8. But what if k is equal to 2? Then this path will be invalid because the cost is greater than k, right? So we don't have to take this path, but normal DP will be taking this path, right? Which is wrong. So we have to track score and cost simultaneously, right? We have to track cost and score simultaneously. So what we do is, instead of using 2D DP, we will use 3D DP, which is maximum score to reach the cell I comma j with the cost c, and where c should be lesser than or equal to k, right? So we will be using this. So what will be our transition for this DP state? So we can reach I comma j from either the top direction, which is from the cell I minus 1 comma j, or from the left cell, that is I comma j minus 1. So these are the two cells by which, from which we can reach to the cell I comma j. So basically, what we do is, we will find the new cost and new score at I comma j. So new cost will be the old cost, the cost present at the previous cell from which we are coming to the current cell, and the cost of the current cell. So the cost of the current cell will be depending on the value. If 0 is there, then the cost will be 0. Else, if 1 and 2 is there, then the cost will be 1. Similarly, we will find the new score. New score is basically the old score, that is the score present at the previous cell plus the value of the cell, right? So this way we will find the new score, and then we check if our new cost is less or than equal to k, then only the path is valid. But if it is greater than k, then we store -1. That means it is not feasible to reach that cell with a cost lesser than or equal to k, right? So this way we'll solve for all the values of I, j and c, right? We'll solve for the all the values of I lesser than or equal to m, j lesser than or equal to n, and c lesser than or equal to k. We'll solve for all the values of I, j and c, and then at the end, what will be our answer? So what we have to do is, we have to find we have to reach m minus 1 comma n minus 1, m minus 1 comma n minus 1, and our cost c can be any values between lesser than or equal to k, from 0 to k, right? So we'll track all the values of dp from m minus 1 comma n minus 1, and with c, and c can have all the values from 0 to k. So we'll take maximum of all these values, right? So whichever is the maximum answer, that will return. So the time complexity of this approach is big of m into n into k, where m is the number of rows, n is the number of columns, and k is the uh, total cost that is allowed to us. So let's try to understand this with the help of an example. So we have taken the grid as 0 1 2 0 and k is equal to 1. So initially in the starting we have taken, as we know, 0 comma 0 will always be 0. So dp of 0 comma 0 with cost 0 will always be 0, right? So we start at 0 comma 0. So our score is 0 and our cost is also 0 at initially at the starting. So from 0 comma 0 we can either go to 0 comma 1, or we can either go to 1 comma 0. So these are two places we can move from 0 comma 0. So first we will move to the right cell, that is 0 comma 1. So at 0 comma 1, what is our value? Value is 1. So what will be our new score? New score is basically old score plus this current score. So score will be 1 and cost will be 1. So now what will be our dp value at 0 comma 0? So dp value at 0 comma 1, dp value at 0 comma 1 with cost 1. What is the score? Score is 1. So that we stored at 0 comma 1 with cost 1. Then from 0 comma 0 we move down to the cell 1 comma 0. So at 1 comma 0 the value is 2. So now earlier score is 0 and the current score is 2. So the score has become 2, and the cost is, earlier the cost is 0 and the current cost is 1. So the cost is 1. So what we store is, we store dp of 1 comma 0, that is dp of 1 comma 0 with cost 1. The score is 2. So now currently our dp is having these three things. At 0 comma 0 it is 0, here the score is 1, here the score is 2. This is what I am showing for 3D DP, right? This is not 2D DP, it is for 3D DP. This cell is 0 comma 0 comma 0. This cell is 0 comma 1 with cost 1. This cell is 1 comma 0 with cost 1, right? Then from these two cells, from 0 comma 1, we can't go in the right because it is out of the grid, so we go to the down cell, and the down cell is from 0 comma 1, we will be going to 1 comma 1, right? So here our cost is 1. So let's see what is the cost to move to this cell. So at this cell we have 0 comma 0, right? From 0 comma 1 we'll move to down cell, and at that down cell we have value 0. So our score will be increased by 0, score plus equal to 0. So earlier our score was 1, so 1 plus 0 is equal to 1 only, right? And cost will also be increased by 0. So our cost was our cost was 1, so 1 plus 0 will be 1, right? So we get dp of 1 comma 1 with cost 1. With cost 1 the score is 1, right? And moving right from the cell 0 comma 1 sends us out of the grid, so we do not move. Then the next movement will be from 1 comma 0. From 1 comma 0 we can move to 1 comma 1 when we will move in the right direction, right? So again the cell value is 0, so our score will be increased by 0. So earlier our score was 2, so 2 plus 0 it will be 2, right? It will be 2. Cost will also be increased by 0, so earlier our cost was 1, so 1 plus 0 is equal to 1. So we get a new score and new cost. So dp of 1 comma 1 is equal to, earlier the value is 1 but our current score is 2, so we take the maximum of both. So maximum 1 and 2 is 2, right? So now dp of 1 comma 1 is 2, right? So the final dp states that we get is dp of 1 comma 1. So we want dp of 1 comma 1 comma 0, it is -1. Then dp of 1 comma 1 comma 1 is 2. So we take maximum of these values, so maximum of these values is 2, so 2 is our answer, right? So let's see the code part. So in the code part we have taken the row number and the number of columns, and then we have declared our 3D DP with all values initially -1, right? And then we have marked dp of 0 comma 0 comma 0 as 0. Then we have used three loops, one for the rows, other for the columns, and the third for the cost from 0 to k. Then if dp of I comma j comma c is equal to -1, that means that a particular state is not reachable, or it is invalid, it is not valid. So if the state is not valid, then we skip that state, so we continue. But if the state is valid, then we move down and move right from the state I comma j. So from I comma j we move down, so we first check whether I plus 1 is inside the grid or not. If it is inside the grid, we find the value of that particular cell which is grid of I plus 1 comma j. Then using the value we find the cost. So if value is 0, then the cost is 0, else if value is 1 or 2, then the cost is 1, so we find the cost. So using this cost we will find the new cost, which is our current cost. C is our current cost, and cost is a cost of the new cell, so we get our new cost. And if our new cost is lesser than or equal to k, if our new cost is lesser than or equal to k, that means it is a valid path. So dp of I plus 1 comma j and new cost is equal to maximum of the value stored there plus or dp of I comma j comma c, that is the current state plus the new value. So this is the score, this is the score, so we store the maximum score there, right? So this is for the down movement. Similarly we find the for the right movement, that what if we are move in the right side, then we find the again we find the new cost, and if the new cost is lesser than or equal to k, then we find the maximum score, which is the current score plus the value present at the new cell, right? So we find the uh, what you call new score and store that new score there, right? So after all the loops for I, j and c has been executed, then we find the answer. And what is our goal? Our goal is to reach m minus 1 comma n minus 1. So we find all the states of m minus 1 comma n minus 1 with different cost from 0 to k. So we'll take maximum of all the states and store that in the answer, and at the end we'll return that as the answer. So I hope I'm able to explain you the solution properly. So if you like the solution, please make sure to like, share and subscribe the